Hello everyone, my name is Shixiong Jin. This is my presentation for EEL 6825 Partner Recognition, University of Florida. The topic I choose is face recognition. Face recognition is an easy way and direct way to distinguish different people. But actually there's other ways like DNA or fingerprint. But face recognition has become a hot area since late 1980s, and there are two common and popular ways to do face recognition. First one is eigenface, use principal component analysis. Second one is facial face, use facial linear analysis. In eigenface, we can see picture from here. If the image is similar to each other's, they will not be in the random position of image space, so they can be represented by a lower dimensional space. The main idea of PCA is we first get the best vectors can describe the variation about the face image in the whole face space. And second, we can take these vectors as eigenvectors. And third, we project the input face image into the face space. And if there are m images of size n multiply n, for training, we can use vectors about size n multiply n, and m of them, just like the picture shown here. And from the first equations, we can get average face. And from the second equations, we can get difference between the single image and the average face. And from the third equations, we can get covariance matrix. But use these ways to get covariance matrix is a little bit hard and too complex computation. So we just replace it with these equations. It is more easy to do it. And from the equation here, these two can help us find the nearest class the input image it belongs to. And finally, it just gives us three consequences. One, the input image is not a face. Second, the input image is unknown face. Third, the input image is belong to a certain class. And from here, we can see the first line is just original face we take from our face database. And the second line, the very left one, is mean face. The rest of them are eigenface we can see. And from these pictures, the front line is original face, and second line is a reconstructed face. We use eigenface to reconstruct it. And it is clearly the reconstructed face is much more similar to each others. So, use reconstructed face to do face recognition. It is good. And facial face. Actually, it is a supervised way, and it makes the within matrix scatter small, but the between class matrix scatter big. So the image from the same class is clustered, and the image from the different classes is well separated. It will not be influenced by the face expressions or light different as much as PCA. And all of this we can see from the picture here. It's very clear. And this equation's first one is between class scatter matrix, and the second one is within class scatter matrix. And we can also use this equation to find the best projection way to let matrix W maximize. And there is one problem for facial face, that is, often the within class matrix is singular. So the way to solve it is just to use PCA to first reduce the dimensions. And all the flow paths can see pictures here. And in the experiment, we just try to explore how will the different number of training image will affect the final recognition rate for the facial face and eigenface. And in these pictures, the blue one represents the facial face. The right one represents the eigenface. And we can see both of them, their final recognition rate just increased with the increasing number of training image. But facial face shows better performance because it can use less image to have better face recognition rate. And I also try to explore why just input a face that people does not into the face database is totally stranger. How many chance the facial face or eigenface will reject it and claim it didn't exist. And also the facial face have better performance. And conclusions. Actually, both the eigenface and the facial face have a good face recognition rate. But if the face resource is very limited and there are not many face expressions and light difference, the facial face will show better face recognitions. And we can just see pictures here, just show the PCA and LDA difference. And now I will just show you about some program I have made. First, we select image from the database. First people, add to the database. First class. And we continue to add face into it. Actually, we'll add 3 images to each person, also first class. And second person, we still have 3 images for the second person. And third person, third class. Okay, after all the image in the database, we just do face recognition. We choose the first people and 8 pictures. Face recognition. The computer just gave us it belongs to the first class. It is very correct. And it gives us distance from the face space. We can also visualize. If we want to know the mean face of alt class, we can get it. And if we want to know the specific class, like first class mean face, we can also get it. C. Actually, at the very first time, we just add 3 images to each person. And later, we'll add 3, 4, 5, 6, 8, 9 images to each person and see what this different number of image training will have the effect on the final recognition rate. And actually, at the very first time, we add 3 images to each person, sometimes the computer will just put the image to a different class. Some mistake happens. But after we found if we increase image each person to more, we will have better recognition rate. And the facial face just follows the same process, just the algorithm is different. After we done the same thing to the facial face, we can just compare it with the PCA and see how different they are, and we finally get the facial face has a more better performance. It can use less training image to get better face recognition rate. Okay, thank you very much.